Hey, welcome in. My name's Kirk Harnack. I'm here on behalf of MaxxKonnect, wonderful company that does engineering for broadcasters all around the United States. And with me today, joining me, is Mike Hutchens. Mike, where are you coming from today?
Right now, I'm in one of the studios that we're currently building for Radio 1 in Indianapolis.
Cool. Now, Mike, as part of your job and your team's job, you install a lot of these little RJ45 connectors that are used for computer networks. And do you see them done incorrectly sometimes?
Quite often, yes.
Yeah.
And some of it comes down to just inexperience, and a lot of it is people just trying to be really fast about it. And I'd rather you be accurate than fast.
And I see a lot of them put on by people who think, well, this can't be that hard. Let me just try my hand at it. And, oh, here's a diagram I found on the internet, so I'll get the colors right. And yet after you do a bunch of them and you do them correctly, you actually find some shortcuts to get them done quickly, accurately, and so they will work the first time and also work 10 years from now.
Absolutely.
Yeah. Now, why are these, I must say that the technology behind Cat 5, Cat 6, that kind of cable, and these connectors, the technology is actually pretty sophisticated. They look simple, but there's a lot of thought that goes into exactly how they work, because this cable and these connectors are actually carrying really high-speed data that kind of looks like radio frequency. It looks like RF. So
Absolutely.
The connectors have got to be right. If we were just carrying battery voltage, no problem.
Right.
But these are carrying something much more fragile.
Absolutely.
We have an example here of how not to do it, and you may have one too. You come across some installations and you end up seeing things like this. Let me hold it there.
All too common.
Oh, and even yours is bad, because why? Tell me why yours is not good.
Well, if you look very carefully in there, if I move out of the way, so there's a little tab in there that's going to press down on the jacket. That secures the connector and also takes the strain and the stress off of the conductors that are crimped at the end.
So when you have a crimper like this, or like some other ones, when you crimp that, there's a tab here that goes in back here that has nothing to do with the electrical connections. It actually squeezes the jacket of the cable so the jacket doesn't pull back. And this is important because the physical proximity of the wires to each other in the right in the right twist, and all that's important and must be maintained as far as possible up into the connector. And that's why, like the one I'm holding up here, is a no-go. And even the one you're holding there, which looks a lot better, but it's not perfect, it's a no-go too. Also, just twisting like this, that doesn't fix the problem, does it?
No. In fact, it makes it worse.
Makes it worse. Okay. So the pairs are twisted individually at different twists in order to get the signal. So we're going to show you how to do it well and do it right. And you're going to kind of talk me through this. So here's just a piece of pretty inexpensive Cat 5e cable. Okay. This is solid conductor. Where do we use solid conductor, and when do we use a stranded copper conductor?
Solid conductors are typically used when you're doing your structured cable. So that would be cables that are run through the wall, through the ceiling, that are going from, a patch bay generally to another patch bay. Stranded cable generally is used for patch cables. Those are going to be the connections from your switch to the device. Like
this one. And I tend to use pre-made patch cables. Do you guys make your own, or do you use pre-made?
It all depends. There are certainly cases where a pre-made patch cable will save you time and effort. And there are other times where you may find that, you need a 19-foot patch cable, and, well, your choices are either 14 feet, which isn't going to make it, or 25 feet, which is too much.
So the first thing we're going to do is strip off some jacket. You've got the proper kind of stripper. I've got a ripper as part of a pocket knife here. And there's other ways to do it too. But when you're doing this, what are you really trying to avoid doing?
You're trying to avoid a cut that goes so deep that you get into the actual conductors. And that's one of the reasons why I really like this tool. You can find it at several different hardware stores. It has an adjustment here for the razor blade. And the reason for that is, on this cable, you can't really see, but I've already marked where I want it cut. Right? So all we're doing is scoring the jacket so it will split.
And you said their key word, scoring the jacket. And the cable that you're holding there looks like the jacket is more stiff, and when you score it, it almost breaks apart. right?
Correct.
And the cable that I have right here doesn't do that as much. This might be some cheaper cable that I don't know, found in the trash can or something. But so I went around using this ripper, but there are other ways to do. Some people use a razor blade. Some people might use a knife.
Pocket knife.
If you use something like this, you stand a real good chance of poking too far in. And the point is, you really don't want to cut into the insulation of the wire inside. You just want to score the jacket. And after you score it, you can usually pull on it and break it. And if you're breaking it off, that's a good thing. Now, and by the way, how much do you choose to strip back?
I generally strip off about 2.5 inches.
Okay. I stripped off a little bit less than that here. What is this string, and what do I need to save it for, if anything?
You don't need to save it for anything. The purpose of the string that pretty much no one ever uses it for is if you do pull on it, it's not going to do it for me here. It'll rip the jacket.
I see. I thought it was also just for added strength in pulling it through conduits and things like that.
Not generally. That's generally what the carrier between the wires is.
Oh, okay. Now, your cable is a higher quality one. Maybe it's Cat 6, and it has a plastic, like, cross-shaped thing to keep the individual pairs separated from each other, right? This cable, which is Cat 5, does not have that internal thing. So now tell me what you do if you have Cat 6 cable that has that internal thing. What do you do with that? Where do you cut that off?
I will generally fold that back so it's right up next to the jacket.
Okay.
Snip it right there.
All right, so what we have coming out of the jacket then is just the 4 conductors.
Correct. Yep.
What if you're using cable that has a shield and a ground wire, which is uninsulated? What are you doing with that let's talk about computer cases. We'll talk about the audio case later, but in computer cases, what do you do with the shield?
The drain wire, you want to try to preserve that, because that's what's going to get crimped with the jacket to create that 9th conductor, the shielded conductor. The foil itself, you can generally carefully trim that back at the same spot as the outer jacket. So it's really the drain wire that we're most worried about.
I realize that because the camera's looking at this from the other angle that I do. I tend to look at it this way. By the way, the color code needs to be going into your connector. That color code, if you forget it, and I always do, find it online. Just what would you Google? RJ45 color code?
Yeah, or Cat 5 or Cat 6 color code.
Okay. And there's an A and a B standard. The A standard, largely not used anymore. We tend to wire everything with the B standard, right?
Correct. Yep.
Okay.
And really the only difference between the two is where the white-blue and white-green pairs go.
Okay. There could be a reason to mix those, but for now, we just do everything with the B standard. Now, I've separated these into white, orange. Well, I thought I did. No, I got them messed up already, Kirk. All right. Orange, white, and orange. White, green, and green. White, blue, and solid blue. There we go. And white, brown, and brown. Okay, that's how they kind of naturally want to come out when you untwist them. I untwisted these by hand, which if you do enough of those, your fingertips are going to be so sore later on. You've got something really cool there to show us, right?
Yeah, we'll put a link into this tool that my friends at Hutchens in Evansville, Indiana created. It is a very simple wire straightener. And if you are going to spend days making these cables, so here's a pair that I've untwisted, but you can see they're still a little kinked. Couple passes through there.
Straight.
Perfectly straight.
Oh my gosh. My fingers are so jealous and envious. All right, a wire. Now, if you do it with your fingers, here I've done it, and sometimes it's helpful to do this a few times to warm the wire up. It tends to make it straighten out better. And I have arranged this. You can see it on in their. First, I did it in their natural color order that just came out. I got them separated, but then we start putting them into the standard for the wiring. So we have white, orange, and then solid orange. Then we have white, green, and then we have the solid blue, and then the white and blue, and then the solid green. So the green pair gets split. The blue pair goes in the middle of the split and gets reversed from
Correct.
the other pairs. And if you do this a few times, you'll start to memorize this, but it's always helpful to go back and check yourself against diagrams. And the last pair, the white, brown, and the brown pair. So now we have this, okay, and this conforms to, I'm showing, let's see, yeah, I'm showing this to you in the correct order. We think of this as left to right, because when we put these in, the little clip is going to be away from us, and it's going to be in this order. But we have to get these all together nice and parallel, right?
Mm-hmm.
So everybody has their own technique. I grab about 4 of these at a time and kind of get them together, and then I grab the other 4. I have a hard time grabbing all 8 and making this work. And then I put the 2 bunches of 4 together, and then instead of worrying about keeping them in order exactly, I get them more straightened out. And then I go back and I check my order. So here we go with the, and sometimes, one will get reversed. Here I am peering over my glasses because I'm an old man. And I got to tell you, this brand of wiring that I'm using, the color stripe is really hard to see. It's not painted on very well. But yeah, these are in order now. And let me hold that in front of the camera. If you compared this, and maybe if you can see that well enough, can you check me on that order? Does that look about right? Now I realize the white with the green stripe is really hard to see.
Yeah, it looks correct.
Okay, yeah, and I always, yeah, okay. All right, so now are we ready to put this in the connector yet?
Not just yet.
Okay.
A couple more things that we want to do to prep. And this would be true for whether you're using a pass-through or a standard connector. Mm-hmm. As you hold your cable up, and mine looks the same, our wires are slightly different length.
Yeah. And I think more importantly, they're a little ragged. The insulation is ragged. They're not cleanly cut off. So if you had to pass these into a little tiny hole, some of them may have a little trouble.
Right. So if you're using a pass-through connector, mm-hmm. what I tend to do, take my nice electrician scissors, mm-hmm. and I'm going to cut them all at a bit of an angle.
Oh, an angle okay. That's a good idea.
That's cleaned up the ends, and now we've got a really nice arrangement for that pass-through connector to slide right on, and all the wires will fall right in place where they need to go.
Now, I got to tell you, a cutter like this does not do a nice, clean job of cutting those off. A cutter like this can do a cleaner job, but it's still going to give you a little bit of frayed action. I like the cutter that comes with this particular crimp tool. This is not a pass-through tool. This is a normal non-pass-through style, but it has a good, clean cutter on it. But I'm going to try the angle. I've always done it not at an angle. Here, let me give it a little bit more of an angle. And that way, you're not trying to shove all 8 of them through at exactly the same time. Okay, so how's that look?
Looks great.
Okay. Now, I'm going to hold this. I'm going to turn this around so it's correct for me. Mm-hmm. And so I've got my orange stuff on the left and my brown stuff on the right. Here's my RJ45. The little clip is going to go. Does that have a name? That clip?
Sure it does.
Okay.
It is.
Okay. And I'm going to put that in there. Now, guess what? This is not a pass-through. And so that's not going to work, is it?
It is not.
Okay, so I need to cut that. Actually, since this is not a pass-through, I don't need to cut that at an angle. I should make it more flat.
Correct.
Okay.
Yep.
Okay.
So
first mistake, Kirk. Go ahead.
If it's not a pass-through, mm-hmm. to get close to the correct length, I will generally place my thumb right where the jacket ends.
Okay.
My index finger on the other side. So I'm pinching that. Mm-hmm. Then I can use my scissors to cut it off straight.
Yeah. Straight.
And you wind up with probably 5/8 of an inch of the conductors there. And that tends to be about right to slide right into your standard connector.
Now, I've cut mine probably 1/8 of an inch longer than or 16th more. The jacket is in, but it's not quite under the part that gets crimped. Now, what I tend to do, if it's that close, I'll push it in a little bit more. Now the jacket is under the part that's going to get crimped in there.
And
Now,
unfortunately, when you do that, you introduce the opportunity for those wires to move from the carrier where they're supposed to be into other channels in the connector. You may wind up with a spoiled end that won't pass your continuity test.
So I'm going to cut off that extra 1/16 of an inch. And now, with this oriented correctly for me, and if you look from the backside, you can see if they've gone into their slots correctly. And the jacket is up in there, no problem. And here's my crimper. So I'll put that in. Hold that in front of the camera kind of well. Let's see if I can turn that around so you guys can see. And I don't know, I have a habit of just crimping the ever-living life out of it. And for some reason, I think it's helpful to hold it a little bit.
Try that now. There are days where I think clenching my jaw helps, and I get worried I'm going to break a tooth.
All right, so to me, let me double check. I can see all the wires. Each wire is in its own passage. None are doubled up, and each one falls under a copper contact. By the way, inside, when I have crimped that, those coppers are actually made with a little spear, and they spear into the jacket of the individual conductors and go and touch the copper, right?
Correct.
Okay. Now, look. What's the difference between that one and this one, other than also the ground? This one doesn't have a boot on it. Do you always put a boot on it before you do this process?
Me personally, I prefer to buy connectors that do come with a boot. It's added strain relief that will help that cable last a lot longer. Yeah.
I just sat down in front of the camera here today, folks, and I'm sorry, but I forgot to go get my little box of little colored boots. But so now you can always if you forget, slide the boot on from the other end if you haven't terminated the other end.
Which can be a challenge if the other end is close to 100 feet away or routed through studio furniture.
Routed through studio furniture, that's right. All right, so it looks like I've kind of done that right. If I did it right, we're going to show the basic kind of tester. These are available for like $8 on Amazon, maybe $10. And you take I have a cable here that was pre-made, just your basic pre-made 3-foot cable. Plug it in there, and it's got a little switch on the side. It's got a fast and a slow test. So if your eyes can follow along, this is the fast test. If it's green, this can go 300 feet away. If you need to test something that, the long cable run. And then this end, you can look at either end and determine, hey, is it working? And if it skips a light, you don't have a connection. Now, this doesn't test for quality. This just tests for presence of proper connection.
For continuity.
Continuity, thank you. This doesn't mean it's going to work. It means at least you didn't screw up royally.
Right.
So,
and in a lot of cases, that's perfectly acceptable. When you're making especially audio cables for studio hub type things, continuity tester is great. If you're making the actual Ethernet cable that's going to go to, say, an axial live wire device or a WheatNet device, you're going to want to invest in something that will give you a little more info. Because then continuity, yes, is important, but the overall quality of the cable becomes far more important. This particular device, made by Fluke, this is my go-to, travels with me everywhere. It will do a continuity test. It also is a bit of a TDR. It will tell you how long the cable is. It has a PoE tester in it, so you can test if your PoE and your switch is correct or not. And it has a nice feature that if there is a problem with one of the connectors, it will tell you which end of the cable the problem is at. Is it at the one plugged into the tester in your hand or at the remote unit? Now, these things are available on Amazon. You can likely find them locally too. They're around $1,500, but also come with some other fun tools that come with it. For example, if you've ever tried to find a cable in a bundle or at a patch panel, this will actually put tone on your Cat 5 or Cat 6 cable that you can find basically with their version of the Fox and Hound.
So what's the other tester you've got there?
So should you need it, This is a product from NetAlly. Fluke also makes several. This would be considered a cable certifier. What this does, it takes everything the Fluke does and ratchets it up. So not only do you get the continuity test, not only do you get the measurement of your length, but it'll also tell you the characteristics of each pair. You know, what is its capacitance, and we'll actually save the parameters in here so you can print a report out later to provide to, you know, the boss, the client, whoever, that, oh no, we made this cable, it's correct, it's certified, it works. So this I tend to use when I'm making connections, again, for an audio over IP environment. Because in that case, with your audio over IP, those packets are coming every 1/4 of a millisecond. So the cables have to be accurate.
Wow. Okay. We have one other quick thing to at least mention, and that would be using what we call pass-through connectors. And I have been, while you've been talking, I've been busy just prepping a cable. So here we are. The cable's pretty much in order, and cut it on a diagonal, and I have a pass-through connector. Talk to me. There's controversy about pass-through connectors. You wire radio stations that have to work 24/7, 365 without fail. Are you using pass-through connectors?
Yes.
Okay. And how's that work for you?
Well, I find the trade-off for the accuracy, which leads to quicker speed on a project, goes up significantly when you're using a pass-through. And if you are using high-quality pass-through connectors, they tend to not be a problem with the certifier.
Is there a brand that you like to use as far as the pass-through connectors and the crimper?
There are. I have kind of two go-tos on my pass-through. Platinum tools. These guys, they're a little more expensive than what you may find on Amazon, but that is exclusively what I use when I'm doing audio over IP. A little newer product on the market, Simply 45. These are also a fantastic connector. I've never had a problem with either the Platinum or the Simply 45 passing a certifier.
So this is probably some off-brand of pass-through, so I'm not suggesting that you use these. It's what I had handy. And the pass-through is called that because, well, as you can see there, the wires pass through, which means you don't have to be so accurate in cutting them to length. You can push that cable on up in there. They come through there. And the key about these pass-through crimpers is they have a shear cutting edge that will cut these off. And if there is... It's got to cut right up against the body of the RJ45 connector. If it doesn't, then you've got little parts sticking out, which couple problems. Some people say that they can corrode, and certainly they can prevent the RJ45 from getting pushed all the way in. It'll click, the little thing will click, but it may not be all the way in. So I'm going to cut that off and pull it out, and it sheared all those wires off. Okay. I've used it for a while, and it does work, and apparently works well. But I can understand why some people think pass-through connectors are not the thing to use, because if you there's more chance to install them poorly because of poor equipment or poor technique.
And generally, I find when the connectors don't go on correctly, it's generally a misaligned or poor quality tool.
Ah, okay. So it's the tool that makes a huge amount of difference.
Correct.
In getting them correct.
I was going to say, one more pro tip from me to you and everybody. One of the other things that I do, so I've got my conductors through there. I've got the jacket all the way in, so we're preserving the twist all the way to the pins.
Yep.
Before I crimp, I generally give all of those a twist.
Interesting.
So it slides through the tool easier.
Yes, it does.
And less mess.
Oh, because you can throw everything all at once, and not have them go. I got to take a picture and put some B-roll in of my desk, because it's I've made a mess here. You have one more tip for not making a mess.
So that's the final tip. That the jar that your connectors came in, I generally save one, and it becomes my trash bucket.
Wow. Great idea. Great idea. So, Mike, what would you say your success rate is in building studios? Lots of these connections for all the IP systems. You got a good success rate?
Well, in this project here in Indianapolis, I've probably personally made around 1,500 connectors, and I do have to admit to one of them being bad.
I hope you've disciplined it appropriately.
I did.
Bad connector. Bad connector. Mike Hutchens, it's been a pleasure talking with you. We got a few more things to do in this series. Coming up in another episode, we're going to talk about specifically cables for Studio Hub, running analog or AES EBU audio through. And, this just blows the mind of IT people when I show them, what? You mean I can plug a Cat5 cable into that and have XLR connectors at the other end? We'll tell you about that. It's not magic. It just makes good sense. So we'll talk about that on the upcoming episode. Mike, thank you for being with us, and thank you for MaxxKonnect being such a leader in tools, techniques, and work in the field, getting studios built and helping broadcasters out. Appreciate you.
Thanks for having me.